Hello everyone, Lays and Lie here. Ready to rate Lays and Lie? Okay, in all seriousness, hello everybody, it is Lays and Lie here. Today we are going to be doing STEP. So, what is STEP? STEP is, I haven't done any of the other typically hard math exams before. I have not done Olympiads, I'll be very open about this. I haven't done Olympiads, I haven't done uh, the Chinese or the Korean or the Japanese exams. So I don't know really how hard any of the other contemporary math challenges are. However, I can tell you that the STEP or the sixth form examination papers are generally considered on the harder end of that spectrum, which includes all the famous Gaokao or IMO, etc. Because what STEP is that it is the introduction, the rather rude introduction to Cambridge mathematics. In order to be admitted, you need to get a good score on the STEP. And what the STEP is not what I am showing you. What I am showing you is the STEP support program. STEP is this. Let's see, STEP Cambridge past papers. So let's look at the most recent step. I do have the most recent step downloaded just as a thing of convenience. Just as a surprise, but this is 2022 step, and you can see it is quite the challenge. In fact, this is as if you took an Olympiad paper and you put everything in high school inside it. Usually Olympiads try to test stuff some stuff is out of syllabus, but they don't usually do terrible integrals. I am pretty sure the IMO does not test integrals. It doesn't test your ability to comprehend like very high level calculus, whereas this will throw everything that is on the table at you and expect you to understand. So complex numbers, matrices, Maclaurin series for one, hyperbolic functions, everything possible that you are expected to know at that point. At that point being the very end of your high school career. So you're taking this in conjunction with your final exams in senior year, or for us British, sixth form, upper six. Yes, so STEP. That's STEP. It's horrible. Why are we doing STEP? As astute viewers who have watched previous streams or even looked at the thumbnails will know, I am not doing STEP. I'm doing the TMUA, and I have, to be honest, not been doing much on that so far this summer. I will kick off later on. We'll perhaps do a few more streams on that later on. But the reason I'm doing STEP is that it's good to prepare you for not just the TMUA, but also Cambridge interviews, because they are a very hard problems designed to test your problem solving. And my problem solving is amazing, by the way, amazing, because, hello, Mr. Cambridge professor, it's amazing. And that's why I've decided to flex that skill upon you all, so that I can prove to you, Mr. Cambridge Professor, that I am in fact capable of handling the Cambridge mathematics. No, not the mathematics program, but the computer science program. Please let me in. So, without further ado, let's begin. You'll notice that I'm starting over with assignment 1, not assignment 2, because I did assignment 1 as a bit of practice, and I found it quite alright. The difficult thing about this is it is less structured, less formulaic, you could call it, than the TMUA. So perhaps a bit less commentary will be around for most of the stream, but we will have to see how we do. Yes. So, 1 second. Let me load something in the background. A funny surprise will be of use to us later. Specifically, what I'm loading is, or at least trying to load, is the live chat, which I always keep on hand. Or at least I try to keep on hand in the last 2 streams, because there we go. So I popped up the chat. just have it on in the background without any of you seeing it because of the wonders of OBS, which allow you to do windows. Where do I put this though? That's a good question. I should also probably put a timer, but it's restful, so we're not gonna. Suppose I'll put it in the corner here. Should be good. Okay, so let's just fold this over. And I've managed to diagnose, by the way, the technical issues that were plaguing me last stream. Turns out it's my computer is broken. It's a hardware issue, which is quite inconvenient, but I've managed to find a workaround after a bit of the empirical method, which is basically me loading into UEFI diagnostics and testing all of the possible combinations of the conditions that made it go wrong. And I figured out that apparently if you start in without plugging your laptop in, flip it over and then plug it in on the first slot, but not the second slot of my USB-C charging ports, then you can actually use the pen fine, because the problem previously was that my pen would somehow stop working when I plugged my computer in. So yeah, we found a workaround. Well, later on I'll try to get a drawing pad, hopefully that'll be more useful. But anyways, I digress. So, you've had a plentiful time to look at the assignment 2. So let's begin. How do I... Oh, wait. How do I keep my chat, like, pinned here? Like, override Windows. Oh, I'll figure it out later. Okay, so, assignment 2, warm up. Simplify this by giving it in factorized form. So this is pretty easy. Say 4x squared plus 9 minus 12x. Minus, doing brackets, just to be safe, plus 1 plus 2x. Which is equals to... which is equals to 14x, and they've asked us to evaluate 1. So that's 3 plus 8 minus 14, which is minus 3. So x equals 1, x equals 2 is merely 3 plus 8 minus 2, so 28, 8, 12 plus minus 8. And yes, that seems correct. Do we need to do any error checking for the warm-up questions? I suppose we get into habit. One of the problems I come up with is that I frequently get things wrong by just silly little mistakes and those chip-off marks, so it's a good habit to get in by just doing some simple error checking. So x equals 1, 3 plus 8 minus 14 minus 3, that sounds correct, and 12 plus 8 minus 28 equals negative 8, yep. So simplify. Simplify this. Ooh, this is partial fractions, I think. Oh no, it might not be actually. So, oh, and another somewhat embarrassing note is that I am very fully out of practice with our good friend A-level maths, because I haven't done any A-level maths ever since my mocks, or at least the end of term, so that means I have very little memory of things like integration by substitution, so I'll probably have to get on track of those on stream, which is quite embarrassing, but here we are. So, what we do here is multiply certain bits. So, for example, we do x plus 1, so we multiply them all to have the same denominator, so this is actually x minus 1, this is y, 1 plus 1, and then this is x minus y squared. Yep, excellent. So now we're just gonna do a lot of multiplying. Example, this cancels this out. This cancels this out. Ooh. This is not, however. Oh, no, no, terrible mistake. This does not cancel out. Okay, so, mistake learned. Let's just be paranoid about it and do this. Yes, so now we can clearly see. Oh, I've done it again. Okay, so I've done it again. I need to be more careful. This is out, this is out. Okay, so now we can quite safely say this, right? Just equals to negative 2y minus 6. Done. And next up, they've asked us to find the possible values of x and y for which it all equals 0. So this is simply y plus 2x. And I suppose I write that out for posterity. Usually I wouldn't, but I'm on stream. And again, always remember the Cambridge professors are always watching. They are omnipotent and omniscient, and we must respect their wishes. So we'll write it all out, and so we can tell if let's see, if y equals 0 or y equals negative 2x, then expression, I should say expression, I can't write out the whole thing, y equals 0. Suppose I'll put it there. Yep. And so next up, triple I, show that this is equals this. So some basic algebraic manipulation is what I am detecting. Quite odd. Okay, so this is quite interesting. What they are essentially asking you is to manipulate this and this. But the thing is, if you start with this on the left-hand side, then you don't actually have a wealth of options available to you. This isn't a difference of two squares, obviously. You can't be getting up to that. So, really, what are they asking? I suppose you could do this, which is quite ugly. You transform it into this. That's got to be squared, right? So that's fundamentally impossible. You can't do different two squares here. So now the question is, how do you manipulate it? Quite difficult, this one. No clue. Okay. I'm not using a tip on that goddamn warm-up. I'm better than that. No, we're better than that. We are better than that. What ways can we manipulate this? Because if you think back to finite automata, surely this expression has at least one way to accept an input and go to another state. Like it surely can't stay in the initial state. So how do we manipulate it? Is the question. Ooh, one thought I have. We could do some version of rationalizing the denominator, which is a thing that we know how to do these days. Oh, I haven't done this in so long. I mean, rationalizing the denominator, not just maths in general. Although that does apply. I have that in a couple days. So x. Oh well, these two cancel out. So this is redundant, isn't it? So yeah, this becomes x squared minus x squared, which cancels out, leaving this one, leaving this value. And for the deduce question, it's trivial. As x goes to infinity, then this is basically equals to this, which is equal to this. Oh, not squared. As x goes to infinity, the 1 becomes kind of irrelevant, so it just becomes x. So therefore, it becomes x plus x, which is 2x. Yeah. So next up, IV. That's annoying, isn't it? Okay, so x quadrupled plus 2x3 plus 2x minus 2x3, so these two cancel out. And finally, the easy bit, which is just copying out the entire expression because it's just one. Yep. Now we've got this, and so this should all nicely cancel out like this. Comes this. Lovely. Yay. So now we have to find the solutions to this problem, which is pretty simple. All you have to do is sub each of these individual quadratics into the quadratic formula, I believe. So this is positive 2 square root 2 plus or minus square root double minus 4. Yep, so this does involve I, which is why it happens. Bottom is just 2, and then or 2, which is the same, being negative this time because that changes, but this does not. So this becomes square root 2 plus or minus 2 to 2 so minus 2i. Lovely. So that's the answer. It's not that hard. Now is the hard. Oh, it's preparation. Oh wow, this is a long document. Okay, sure. So, let's go on ahead and go to preparation then. This might take me longer than the initial 45 minutes I expected this to take. How long have we already spent? Let's hope it's less than 10 minutes, or else I'm going to be very embarrassed. I've spent 20 minutes. I'm very embarrassed. So, to work, sketch this line. Suppose I'll be nice and mathematical, the temporal origin, the labeled axes, and it is this. Where this is -2, and this is 1. This is 2, this is 1, this is 3. So 2i, I. Oh lord, this doesn't seem nice. So, sketch the line. Oh, we've got to show it, don't we? Okay, so it's negative, so it goes this way. actually it is doubled, so it will go down a bit steeper than usual. It's not terribly straight, but it is straight enough. So yeah, this is 2. This is steep. So to show that the greatest value is 4 plus c, I guess we can kind of split them in half. So for y equals negative 2x, or negative 2 minus 2, our biggest value is 4. So f of x plus a, biggest value is this value of f of x plus a, so it's 4 plus c. Greatest. And we can also tell that negative 4 plus c is least. Yeah, not so hard. Triple I, oh my god, there's 7 of these? Sketch ymx plus 1. Which is, again, starting here, this is always 1. In the cases that m equals 0, it's just this. In the case that m is larger than 1, it's this. In the case that's smaller, in the case that's smaller, it's this. So this is m larger than 0, this is m smaller than 0, this is m equals 1. Done! The m equals 0. So done! Oh my days. What are the greatest and least values of... Why are we doing this? God damn. Okay. So for m equals 0, greatest is equals to, you guessed it, 1. If m is larger than 0, then the smallest value... Smallest? Wait, no, what am I doing? The greatest value is negative 2. Negative 2? No, wait, no, it's positive 2, isn't it? It's positive m plus 1, and this 4. I didn't expect stuff to be this boring, to be honest. IV, sketch the parabola. Really, dude? It's not that hard. You translate this to the right, so you put it here. One. Fantastic. It's truly shocking. Greatest is smallest. So the smallest is this. Oh, I need a tissue. Okay, 1 second. Let me just... Unfortunately, as men, we are in the habit of sneezing. As we all know, women do not sneeze. They do not have the ability to do it. How do I go back to... Yep. Okay. And that's why everyone wants to be a woman. Especially me. Anyway, let's go back to mathematics. The greatest value is... It's 9 because... well, think about it this way, right? The cutoff for negative for positive 2 is here, the cutoff is here, since this is farther from the minimum point, then we know that this is going to be higher. So this is just a simple plug-in, and so it becomes negative 3 squared, which is 9. Yeah, done. So v, v x equals this. What are the greatest values? What are the least values? Oh, I don't know. Maybe it's the same thing as we did before. Okay. So actually, let's try and run a nice graph at least. Yeah. The greatest value is 15. Greatest. Smallest is... Smallest is... I think it's just 1, yeah. So yeah, the smallest value is here. The greatest value is here. Nothing that bad. Nothing that bad. VI. So please tell me step question is like fun. Should be interesting. So, we are looking at VI, write the expression into complete the square form. Which we should be able to do fairly easily. Like this. And sketch the graph. Or here. So as we know, it's negative P and Q that form the turning. So this is the turning point. So that means our turning point is 4, 5, which is somewhere here, here. Means that actually I made this terrible oopsie. Redraw this graph and make the top bit a bit larger, so it looks like this. And when x is equal to 0, then this is 21. Yeah, should be 21. Now, actually, they've been really specific, and they've told us... they've not been very specific, and they've not told us to draw the graph anywhere, so this is fine. In the range 0 to 5. So 5 being here, right? So that's 5. So we can clearly tell from this graph, greatest is 21. Smallest is probably going to be the minimum point. So that is 5. And we figured it out. Wow, I love doing basic elementary mathematics. I love teaching my brother mathematics. Because this feels like teaching my brother mathematics. Sketch the curve! Wait, what? Okay, no, I need to wake up. What? Sketch the curve. For this. Hold on. Okay, so what it's asking is pretty odd, I guess, but this is still a complete the square question, isn't it? Like, you could just do complete the square here, Nope, 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 that's k. So do this. So now we know that the turning point is I think. Yeah. I guess we also want to know the roots. Which are these? So we know that there must be one root here, and the other root is probably going to be somewhere. No, we don't know where the root is going to be. Because k can vary from -2 to 2. So this could be anywhere in this area. Hey, am I being dumb? Okay, let's reassess. So this is the curve they've given us. Completed the square, we've got the turning point, we've got the roots, which are 0 or -2k. What information can we get out of this? I'm looking at the y coordinate, the turning point, and I'm thinking this could be useful for us because it's squared, which means that it's gonna be, it's definitely gonna be negative. So we know that the turning point is somewhere this. Oh, actually no, we know that the turning point is somewhere here. That's slightly useful for us. We also know that it's gonna be a minimum point, but that really is it. I suppose we'll just draw like this, right? And we can just say it's 0, we can say this is 2k, we can say this is that. But this is the information we've managed to figure out, and that really is it. Now, let's look at what are the greatest values, right? So g and L, because I'm tired of writing them both out. I probably should have done that earlier on. G is gonna be pretty obvious. No, it's not, actually. Yeah. Okay, let's go figure out the least value, because the least value is going to be this. And so that means the least value. But okay, wait. So let's just check. Is the least value always going to be in the appropriate domain? It probably is. That's good to hear. Because k can vary from -2 to 2, which means it will always be in this specific domain. This domain. This. I can't gesture with my pen very well, but it's always going to be in the domain. Okay, so that means that this is just going to be k, negative k squared. Greatest value, however, is odd. Okay, so one way we can look at it is if k is as far away from the turning point as possible, that gives it the most time, kind of, the most distance to increase. So that means that k at -2 and x being a -2 would make the largest value because here is -2, and in order for 2k to be positive, you've got to have k also be negative. So now we are looking at 8 plus x squared, which is 4, so 12. Actually, that means we can also determine a value for this. So negative k squared is just going to be negative 4, I think, -4, which is what we hope to be the case. Should be right. Yeah. So, let's settle it. Lovely. Oh, they've actually given us a hint. Use the same techniques as in part VI to help you sketch the curve. What techniques? Oh, complete square. Right. So, finally, after, let's check the time. After 36 minutes of desperate wailing at ridiculous quadratic questions that, honestly, I don't think were that necessary, we finally arrived at the actual plot. The plot relevancy has been achieved. We have reached, what do you call it now? One second, I'm messing with my OBS so that you can all see quite clearly what we're doing. It's hard with my finger. Oh, no, I think this is right. Yeah, okay, this works. So, the step question. Find the greatest and the least values of x plus a. Distinguishing carefully between the cases b larger than 0, b equals 0, and b smaller than 0. G and L. And so the way they've phrased this makes me think that it's gonna be different for these. So let's just try and figure it out like this. Actually, we can draw a nice table. So, like this. Right. And so let's figure this out. So the easiest option is, well, if b equals 0, then it's just a. So this is just going to be a. Shocking! This is going to be a. Ta-da! We figured it out. So if b is larger than 0, and obviously we want x to be as large as possible. So it's going to be 10b plus a. And obviously the inverse is true for the least, which is going to be -10b plus a. And obviously the reverse is going to be possible for this and this. So that is the first part of the step question. 3i. Now the hard part, II. Find the greatest and least values of cx squared plus bx plus a, where c is larger than 0, larger or equal to 0. Oh, I thought it was going to be larger than 0, because usually in these you want to make it like strictly a quadratic and not any lesser expression. But it's good to know that it's larger than 0, so that means that it's always going to have a minimum point. For -10 smaller or equal to x smaller than or equal to 10, distinguishing carefully between the different cases of b and c. Let's read the discussion. First is the use of a, c. This question, okay, let's start from the beginning. This question has some features that are very typical of start questions. First is the use of letters, a, b, and c in this case, rather than numbers to make it less more general. Correct term is parameters, x is a variable. In each case, you give the answers in terms of the given parameters, which we have done. Second, though you are not told to draw sketches, you should do so. It is much easier to work on the different cases if you have sketches in front of you. Think back to question 2 to help you do this. Good advice. Sound advice. So let's draw a sketch. Let's draw a sketch. Draw a sketch. Draw a Shrek. So first, let's manipulate this a little bit algebraically to obtain a nice form that we can actually transform a square into, which is just going to be this. This should be familiar to anyone who has derived the quadratic formula by themselves before. What the hell is playing in the background? I turned this music on. It's my music, but I turned it off. I don't know what this is. I'm not hood like that. I'm not hood. I'm sitting in my room doing step questions to a live studio audience. What makes you think? What makes you think that I'm hood? I'm applying to Cambridge. Cambridge is not hood. Name one hood person that came from Cambridge. So I've decided to turn the music off. Genuinely, what is this? Okay, okay. This is gaming drum and bass, which I evidently thought was a good idea for this. It was not. Can I just fast forward? Oh, this is fire. Okay. Yes, this is much better. Yeah, okay, yeah, we can vibe with this. Alright. So, find the greatest and least values of this. So, let's. Oop. So, this is going to be our turning point. Maybe we use the quadratic equation. So, we can just do a quadratic equation. It's this. And yeah, those are our roots. Doesn't help, but we know that now. Yeah, so those are our roots. Okay, 1 second. Hello? I really hope that this is starting working by now. Hello? Oh, hey, it works. Lovely. So, back to the book. Sorry for the unscheduled interruptions. I am back in the studio where I usually do this. I don't know why I decided to use my room today, but poor judgment aside. Poor judgment aside, we are back. So, let's begin. Reconvene on the step question. So let's. Is that book? Oh, no, it's not. So first of all, let's move this slightly downwards so we can go ahead, work on it more effectively. So, oh, so, come on. 0. So now, I've said so many times, but I've not begun. Find the greatest and least values of this quadratic. I think we should distinguish the case if BC is smaller than 0, or smaller than -10, then that's one case. Then least equals one case. Least equals this if. Oh wait, I forgot. I'm on stream. I have to explain stuff. Okay, so right. So we've got our turning point. We've got our lovely turning point, and we've got our lovely roots. So now I realize now that the roots are very important. Turning point singular. Now I realize that the roots are very important to us because, well, our question has nothing to do with the roots, but the turning point is quite nice because it means the minimum point. We know it's a minimum point because well, it said so. The coefficient for the x squared must be above 0, so that means it has to be a minimum point. And looking at how we've done the previous question so far, we know that there are different cases. So one possible case is the minimum point is within -10 and 10, which means that it's here. In which case, it's obvious the least value is the minimum point. However, there are other cases. One of these other cases, what is happening to my computer, is that the minimum point is somewhere here, in which case the smallest value is here, or the minimum point is here. Oh, terrible drawings. How to do this? Yep. So the minimum point is here, in which case it's here. So we have to distinguish between those cases in a way that is good for us. I also believe that the greatest value probably has something to do with this. If it's larger than 10, and if yeah, so the way that we can distinguish between those three cases I just discussed is looking at the x-coordinate. So the x-coordinate, if it's smaller than 10, then it's here. If it's, and vice versa, basically. Vice versa for the other three cases. And the remaining case is if -10 is here, it's smaller, or equal to. Yeah, so if it's equal to or smaller than 10. So L is equals to that, and G is equals to that. Lovely. So we figured out our three cases, and now let's get to kind of working on each of them. And I'm beginning to realize my critical mistake, which is that these are all really long, so let's move these a bit. So let's first work on the smallest case, which is if x, oh god, if x is here. Here. How do you do that? If x, well, the smallest point would just be here. So we can just sub in -10 into the entire equation, which means that it becomes 100z minus -b plus a. Easy. And for G, the greatest value is going to be the one that's farthest away, which is also going to be, let's see, plus B, plus 10B plus A, because it is going to be like this, so that's going to be the largest value. So going and correcting all of our work, now let's look at if it's in between. So if it's in between, then the smallest value is just going to be our lovely turning point, which we've already located. So it's just going to be that. And the greatest value is going to be... So the greatest value could actually be different. If it's here, if the turning point is located between -10 and 0, then the greatest value is going to be here. If it's between 0 and 10, then it's going to be here. So actually, we need to further differentiate this. Differentiate? Not in terms of like calculus, but in terms of copy, and I guess. How do I paste? Oh, I just returned it. Oh, and my OneNote stopped working. That's it? Yep, it's definitely. Oh. No, that's a big problem. So let's restart very quickly. Let's go back. Paste. Ooh, why have you pasted there? That's terrible. Slowly move this back. Oh, everything's so much working here. Yep. If it's 0, that's a special case. It doesn't matter, like, at all, because it will be then in the middle, and the value at -10 and 10 is just going to be the same. It will be symmetric, so it doesn't matter to us, which means it doesn't matter. We'll just leave this to be equal arbitrarily. Least point. So least point is always going to be the same, but the greatest point is going to be 10 here. So x equals 10, which is plus. And for this one, it's going to be minus 10b plus a. And finally, one more case to furnish, which is this one, which is if it's larger... If it's larger than 10, which, removing all of our shoddy working, is going to be like this. So this is going to be our least point, which is going to be 100c plus 10b plus a, 100c minus 10b plus a. Yep, so now we've got our working, and we've completed our answer. Lovely. So, now let's do the simple warm down. The step question ended up being much easier than expected, but I guess that's sometimes how things go. It'll definitely get worse later on. Warm down. 4 children raced each other. A, B, C, D. I love when children are named alphabetically. It makes it very easy for us to put them into variables, which is what you frequently do with misbehaving children. Put them into variables, yeah? Limit their degrees of freedom. First, they raced to the chestnut tree. Then they raced back. A was fourth to the race to the tree. The person who was last to the tree managed to win the race back. The person who won the race to the tree was third on the way back. The person who was fourth... Okay, so I'm looking at this and I'm really bored. This is really boring. So, the way that we could do it is just say to the tree, to the starting point, ta-da. So now let's draw 1, 2, 3, 4 lines of first, second, third, fourth, and fifth. We know that A was fourth to the race to the tree. We know that some X was last, but managed to win it. We know that B was fourth on the way back. The person who won the race to the tree, some Y, was third on the way back. We know someone who was third in the race to the tree was second on the way back, some Z. We know B, so I already wrote that down. We know C, so Charlie reached the race before Daniel. And we know that Charlie got back to the start before Emily. So C larger than B, and C larger than E. And so we know that there is only one way in which they all completed the race. We know that B is here and A is here because of the pigeonhole principle, right? There's only one hole in which B can go, and there's only one hole in which A can go. And so now we have only got 3 left to determine, where we know that C was better than both of them. And X was the last out of the 3, right? X was the last in the first race, so C cannot be X, and Y was the last of the 3 in the second race, so Y cannot be C. So that means that X and Y can't be C, so Z has to be our wonderful C. And so that means that Charlie got back to the start before Emily, so Y has to be C. And X has to be, therefore, the foolish Daniel D. That is the answer. We've solved it. So, that's that. Overall, quite a mediocre assignment. I didn't like this assignment very much. I will check the answers at some later point. Probably today. It depends on how I feel. So yeah, that's our assignment. How long did it take overall? I'm hoping less than an hour, but it was just an hour exactly, so we'll have to deal with it. Now, let's go and look at the assignment. This is the second assignment, which is the one we just did. A logic puzzle, graphs, hints, but no extra fun stuff. Sometimes there's further reading that you can read about, which is quite fun. I don't think watching videos is quite right. But I have seen the monkey and coconuts problem before, so I won't be able to talk at much length on it, but I do recall some parts of it. It was quite an ingenious solution, I think. I don't remember anything about it. It had something to do with equations, maybe even numbers. We don't know. Okay, wait, what is this even about? Okay, so it's basically about for notation. I suspect there's gonna be telescoping involved. There's some warming down. Lovely. So let's go evaluate some numbers. Assignment 3, evaluate this. So we can get started very easily by drawing another lovely graph. Where we know that this is pi, so this bit's not relevant. So let's redraw this graph. Because we know that the large value here is just gonna be, you know what, it's just gonna be pi, so here. So we're taking slices out of this. One, two, three. 5. And yeah. So yeah. Let's add this together. So it's basically 1/6 pi is 30 degrees, and that's, of course, half, and half again because it's mirrored, and then the square root of 3 and square root of 3 again, square root of 3 half, then the square root of 3 half again because it's mirrored, plus 1, plus 0 because of that. Therefore, our answer is 3 plus square root of 3, 2 plus square root of 3. Let series, which is n terms together, simplify, find a formula. Okay. Okay, so reading the question, right? Let the series equal this mess, which is equals to n terms together. That's confusing. Is it really equals to n terms together? For example, if n was 2, then it'd be this. That's equals to 1 term, right? Have I just completely forgotten how segment notation works? Just Google segment notation. Look, I'm very poor at memorizing things. Okay. The last value. So. Oh, I am a fool. So it is inclusive. Okay, so we actually here we missed out on 0. It doesn't matter because sine 0 equals 0, but yeah, I am a fool. It is actually, in fact, correct. I am a fool. So yeah. If I equals 0, then the first term is actually I equals 0. As opposed to I equals 1. Oopsie doopsie. Let's just write this out before I keep embarrassing myself. Yeah, so, oh, I'm starting to make a lot of mistakes, but it's fine. Look, I always have this little period where I get a little tired, and then we'll pick right back up. So, figuring out the series and then writing down this, how do we simplify? We could just do plus 1 minus this. Yep. Yeah, we can combine them together. Wait, this is deducing the notation, isn't it? Okay. Waking up now. This is part of the derivation for the geometric formula. It's geometric sequence formula. I don't remember much of it, which is why I'm struggling. But this so far seems coherent. Like I've written out things correctly. But I can't figure out how to. Okay, so we need to figure out a formula for this. How do you do that? It's done by some kind of telescoping, isn't it? Ah, I see now. Okay, so what you do is, okay, so it is telescoping. So basically, what telescoping is, it means that terms, most of the terms cancel out. So, for example, if you wrote down a sequence like r squared, r cubed, r4, and so on and so forth, and then you minus it by sequence that was like r squared, no, just r, and then r squared, then r cubed. Then actually, this one cancel out, but this would, but something here, and so forth. And then you just be left with ri here and the original minus r. So that's what telescoping is, and it's applied quite a lot in TMUA questions, which is why I know what the term means. And this is that. This is literally just that. I just can't figure out how to do it by writing it down in like a nice way. I mean, I could just write. Come on, please. Oh, damn it. Okay. My computer finally broke. It took a while, but it did. I thought you were charging the entire time. I'm 28. You bastard. Oh, son of a bit. Okay, so I've discovered the problem, which is that my computer wasn't charging, and that's why the issue wasn't occurring. Oh, that recontextualizes the testing I mentioned at the start of the stream a lot more. Shit. So, how do I deal with this? Friendship? Friendship? Oh, hey, it works now. Okay, we're just gonna. Okay, let's just do this question quickly. So, R. Oh, boop. R minus 1. R2 minus R. And it stopped working immediately. This is gonna be a serious problem, isn't it? Oh, hey, it worked. So, let's just keep going. And so on and so forth. I guess plus. So, this cancels out, this cancels out, and this cancels out, so forth. So now all we're left with is I minus 1. Yeah, r to the power of 1 equals this. Yeah, so we figured it out. When r equals 1, define. Aha! It's broken. let's just keep going. Right, it's undefined. Right, sorry for that pause there. Thinking about this. It's a mess, isn't it? A streamer who can't, stream without a pen. It's not really a man streamer without a pen. It's not much of an anything creature. Not my pen that's broken, it's my computer, which is already. So I can replace a pen, I can't replace my computer as easily. Right, so if we know that R is, the magnitude of R is below 1, what can we say about Rn as n gets very large? L goes to 0. Okay, unfortunately I will have to cut the screen because my no, not my camera, but my pen is broken. Thanks everybody.